Jai Bharat World Student. In last lecture we have discussed about the counting principle. Okay. Some rules regarding counting principle, and we have seen 5 to 6 example on counting principle also. Okay. So now in today's lecture we will discuss about permutation, and then next lecture we will discuss about combination. Okay. Permutation and combination. Okay. So permutation, an arrangement or ordering of a set of object. Arrangement of a set of object is called permutation. Okay. Just like in counting, there are some condition for and end, addition and multiplication. Okay. Here is also one condition, that order that we arrange the object is important. Okay. Order is important. In permutation, order is important. Okay. We have to just arrange the set of object in given space. Okay. So now let's discuss some basic examples so that you can get the better idea of permutation. Okay. Consider arranging a 3-letter like A, B and C. How many ways can this be done? Okay. Now we have 3 space, 1, 2 and 3. Okay. We have to make ABC look like put the and make the 3 words, anything 3 words, like they have given also, you given here like if I add in first step as A, then B, A, B, C, then also if I changes B and C position, then A, C, B. Let's start with first word as a B, B, A, C. Okay, interchange these two values, B, C, A. Then let's start with the C, A, B, and let's interchange these two. Okay. Now here you can see no more arrangement can be done for these 3 letters. Okay. So here you can see that we have 3 space available and 3 words are to be added. Okay. So if you count number, there are 6 numbers. Okay. But this is a basic question. In permutation we get the difficult question, then we cannot get this write down all the number and then count all the number. Okay. We have to collect with equation with formula direct how many arrangement can be done. Okay. So now for this example, how can we use the formula? Okay. So first of all, in first step there are 3 words. Okay. So I can add any 3 number. Okay. So let's just like A, B and C, can any number I can add. So write down here 3. Okay. So if I use as a first word in A, then A word is used, so we have only 2 choice. For second spot, okay, for second spot only we have 2 choice, B and C. Let's say example, you have used the B as a first space, so what do you choose? Do you have for the second space? 2. Okay. So if one word are used of first space, then for the second space you only have 2 choice, 2 available to choose from. Okay. It's either B or C, it's either A or C, or either it is A or B here. Okay. Now first 2 words space are done. Okay. So for third space we only have 1 choice, because we cannot use a double A or a double B or triple A. Okay. Repetition are not allowed. Okay. So for the third space we only have 1 word. Okay. Multiply this 3 number and we get the total number of arrangement. 3 into 2 into 1 is equal to 6. Yes, we get the answer as a 6. Okay. So from this formula we can calculate arrangement of any given space or object. Okay, so let's start with some theorem of a permutation. Okay, you all know what is factorial, n factorial. Okay, n factorial means multiplication of up to 1 and decrease one number. Okay, n factorial means n multiply decrease one number n minus 1, multiply again decrease one number n minus 2, multiply again decrease one number, and up to 3, 2 and 1 number. Okay, factorial, it's called factorial. Okay, we require this factorial theory in our permutation concept. Okay, first theorem, arranging an object. Okay, in general, n distinct means different object can be arranged in a n factorial way. If there are different object, then we can arrange in a n factorial ways. Direct answer. Okay, example is, how many ways can 4 different register arrange in a series? 4 different register be arranged in a series. Okay, different, here word they have given different, so we can use this formula n factorial. So their number is 4, so answer is our 4 factorial. And how do we calculate 4 factorial? 4 minus decrease one number 3, decrease again one number 2, decrease again one number, last we have to go through the one number. Okay, so 4 into 3 into 2 into 1, it is equal to 24 way. There are 24 ways to arrange register in a series. Okay, theorem 2, number of permutation. Okay, now the number of permutation of n distinct and different object taken r at a time. Okay. So r at a time means they have only given few spaces. Okay, they have n different object, but they have only given few spaces. Just like say, if in mobile shop there are 5 phones available, but I can choose only any 3 mobile phone. Okay, so there are 5 phone, but I can only choose 3 phone. Okay, so taken r at a time, then we have to use this theorem. Okay, so denoted by PNCR. Okay, it's called PNCR, where repetition are not allowed. This formula is also we have one condition, which is repetition are not allowed. Repetition means I cannot choose same object, just like previous example double A. Okay, for this formula you cannot choose same two repetition. Okay, so what is the formula for PNCR? It is you have to remember this formula, n factorial upon n minus r whole factorial, n factorial upon n minus r whole bracket in factorial. Okay, you have to remember this formula for the our next example also, and also for the probability chapter. Okay, if you use PNCN, there are 3 phone, and we have to choose 3 phone. Okay, so what are the arrangement can be done? Okay, it is n factorial. Why? Because here n minus n 0. You have to remember 0 factorial is equal to 1. Okay, so 0 factorial is equal to 1. So here we get our first theorem, n factorial. Yes, here n factorial, there are n different object, and also for choosing the spaces, there are also n spaces available for choose for arrangement. Okay, let's solve these types of example. In how many ways can a supermarket manager display 5 brands of cereals in a 3 space on a shelf? Okay, one supermarket manager are there, they have 5 different brands of cereals, and for the cell they have only 3 spaces available. Okay, so how many arrangement can be done? Okay, so we only used to formula of PNCR P3C5, where n is equal to 5 and spaces is equal to r is equal to space. So 5 factorial upon 5 minus 3 factorial, 5 factorial upon 2 factorial. 5 factorial means 5 into 4 into 3 into 2 into 1, and 2 factorial is 2 into 1. Okay, 2 cancel, 1 cancel. 5 into 3, 4 into 3 is equal to 60. Okay, so you have to use the remember this formula to solve these types of example. Okay, let's discuss another example. How many different number plates for cars can be made if each number plate contains 4 of the digits 0 to 9 followed by a letter A to Z, followed by a letter, only one letter? Okay, how many different number plate for cars can be made if each number plate contains 4 a digit of number 1, 2, 3 and 4 by followed by a space of one letter A to Z, anything from A to Z. Okay, they have asked two questions A and B. A is no repetition of digit is allowed. If I use for the first space as a 1, then I cannot choose anything as a 1. Okay, I have to choose other than 1. Okay, 1, 2, 3, 4. Yes, just like this, 1, 3, 5, 6. Okay, no repetition are allowed. And if a repetition allowed, then how many number plate can be made? We have to calculate both this. Okay, so first of all, for this 4 number, particularly this 4 number, okay, we have 10 possible digit number, like 0 to 9, it's called 10, 0, 1 to 9 and 0, it's 10 possible digit. And how many spaces for available for the selection? We only have to take 4. Yes, 4 spaces, 4 digit. Yes, so we can calculate. Yes, 10 P4. Yes, so what are the formula for 10 P4? 10 factorial upon 10 minus 4 factorial. Okay, here they have also given one condition followed by a letter A to Z. Here anything A, B, C. Okay, so here 1, 2, 3, 4, we have select 1, 2, 3, 4, but B, 1, 2, 3, 4, but here C. Okay, so there are how many numbers are available for A to Z? There are 26. Okay, so if one selected number has a 26 different, and another 2, 3, 4, 5 also have 26 other, so we have to, what do we have to? We have to multiplication with 26 number. Okay, so no repetition for the 10 P4 multiply by 26. Okay, we have to calculate, and here is the answer, 1,31,040. Yes, okay. Now let's say they have given here 2 spaces for the letter. Okay, so how do we calculate? Just like this, 10 factorial upon 10, and we have 26 letter and 2 places to choose from, so 26 minus 2 factorial. Okay, for this example they have only given one letter, but let's say they have given 2 letters, just like our number plate in Surat. Okay, they have given 2 number like M, L and 4 digit number. Okay, so how do you calculate? You have to use both the permutation formula. Now second, repetition of digit is allowed. Repetition means you can also use 0, 0, 0, A. Yes, 1, 1, 1, 1, A. Here for this calculation we have not used the repetition. Okay, so how do we calculate repetition? Simply Okay, how many numbers of digit are available from 00 to 999? Simply 10,000. Yes, 00 to a maximum number is 9999. Minimum number is 000. So how many numbers are available from 0000 to 999? 1 to 999 means 999 over, also we have to calculate 000. So there are 10,000 number. Okay, and 26 number for of A to Z. So multiply by 26. So there are total this number of arrangement can be done with repetition. Okay, so for this example you get the both the idea how repetition work, if there was no repetition and if there are how as repetition is allowed. Okay, so for both the you have to calculate like this. Okay, next theorem 3, permutation of different kind of object. Okay, they have given different kind. Here we have only same kind of object. Now here we have different kinds of object. Like just like say the number of different permutation of an object which have n are one of one kind, n2 are of second kind, and just like nkr of cat temp. So how do we calculate? You have to use n factorial upon n1 factorial into n2 factorial into n3 factorial up to nk factorial. Okay, let's see example so you get the better idea how this n1r of one kind works. Okay, in how many ways can the 6th letter of the word mammal be arranged in a row? Okay, now they have given word and we have to arrange. Okay, now let's say I have to manually I have arranged. Okay, so this third word, let's say I have interchange these two. Okay, so what word will be become? Here you can see that they are both the same word. As I shift a number of position, but both the words are same. Why? Because here both m are the same. So if I interchange these two position, but word will remain same. So this both are count as a 1. Here also if you interchange with this m also. Okay, so now how do we calculate these types of? Okay, we have to make the group of group. Okay, so there are how many words are there? 6. So here n factorial means 6 factorial. Okay, in divided by you have to use how many m's are there, common number. Okay, so here 1, 2 and 3 m are there, so you have to divide it by 3 factorial. Okay, here also we have 2a, 1 and 2, we also have to divide it by 2 factorial. Okay, so you get the idea. Okay, so we can get the right answer for this arrangement. Okay, okay, next theorem, arranging of object in a circle. You have to arrange object in a circle. Okay, for object in a row, our first theorem, what is the first term? N factorial, and there are n spaces available and n object are available to choose from. So there is our first theorem n factorial. But what are the arranging way in the circle? Okay, so there are n minus 1 factorial ways to arrange n different object in a circle. Okay, so you have to remember this formula. For circle you have to use n minus 1 factorial. Why? Because just like say here a, b, c, d. If I interchange this a and b number, a, b, c and d, Here you can see that for the circle these two are same. Even if I change the position of all the fourth letter, but for circle this is the same. Okay, so we have to deduct some of the arrangement number. Okay, so here the example is formula is n minus 1 factorial. So in how many ways can 5 people be arranged in a circle? Simple, you have to deduct 1 and then you have to use factorial. Now say they have not given circle and given the row, so how many ways are there? Simple, 5 factorial, our first theorem. Okay, for circle we have to deduct 1 first and then we have to factorial it. Okay, next example, some little difficult. In how many ways can 6 girls and 2 boys be arranged in a row? Here they have given arrange in a row. Okay, without restriction. First is say without restriction. No restriction are allowed. Okay, so there are 6 girls and 2 boys and they have given no restriction. Okay, so we have how many people? 8 people. We have to not consider that they are girls or boys. We just have to arrange. Okay, so how many ways can be arranged? 8 factorial, simple, our first theorem. Okay, now here our B option, such that 2 boys are together. They have 8 spaces are available, 3, 6, 7, 8. But anywhere there you have to put boys, both boys should be together. Okay, so how do we calculate? Just like they have given together, so what we will do, we make them one group. Okay, one group, and we assume that this is only a one space. Okay, we assume that this is the only one space is available. So now how many spaces are available? 1, 2, 3, 4, 5, 6 and 7. Yes, right? Okay, so there are if we combine these two, so we have 7 people and 7 spaces available. Okay, so how many way can be arranged? 7 factorial. Okay, 7 factorial. Yes. Now one point is also here B1 and B2 also can change their position. Both will remain together but can also be change their position just like B2 and B1. Yes, so how many ways can this be done? 2 factorial. 2 people and 2 spaces are available, so 2 factorial. So our last answer will be 7 factorial into 2 factorial. Okay, you get the idea. So how do we calculate these types of example? See, such that 2 boys are not together. Here B is 2 boys are together, but C is said such that 2 boys are not together. Okay, this is somehow difficult from to solve from our formula. Okay, so we have to use the common sense. Okay, now here we have calculated total numbers of way for the 8 people. Okay, here we in B we have calculated we say 2 boys are together, 10,000 where 80 is the arrangement that 2 boys are together, and we have to calculate 2 boys are not together. So how do we calculate? We simply differentiate between these two numbers. Okay, so we can get the number of that we can get the number of that 2 boys are not together. Yes, this is the total number and this is the when 2 boys are together. So we simply cancel out from total differentiate between these two number, total number minus 2 boys are together. So we can get the idea that number of ways that 2 boys are not together. Yes. Okay, next example. How many numbers greater than 1000 can be formed with the digit 3, 4, 6, 8, 9 if digit cannot occur more than once? Okay, they have given no repetition here. No repetition. No repetition. How many numbers greater than 1000? They have given 5 number. Okay, so 1000 sorry, they have not given number. So 3, 4, 6, 8 is also greater than 1000. Okay, this number is also a greater than 1000. 5 number. Okay, so what will I do? First of all, I will calculate for 4 number, and then I will calculate for 5 number. 5 spaces are available. Okay, so we have 5 numbers, and how many spaces? 1, 2, 3, and 4 spaces are available. So how do we calculate p by 4? Our third theorem, 5p4, 5 factorial upon 5 minus 4 factorial. Okay, and our next one is 1, 2, 3, 4, and 5. 5 spaces and 5 numbers are available. You can also use direct 5 factorial, or you can also use this now 5p5. 5 minus 5 factorial, 0 factorial means 1. Okay, so our total number will be 240. Okay, so from this way we can solve these different types of example. Okay, now here it is your today's assignment question. Screenshot, take screenshot of it and solve and write down in your book or page and upload it in RNWIET application. After that your attendance can be marked. So here now today's lecture is